as they detected. Sketch mode constrains the geometry but removes the constraints, and set decimals changes the decimal precision of a selected dimension or a cell. So now let's get another interesting part. So geometry, when it's created, it has got these 2 points. These are called constraint points, and you can relate geometries using geometrical constraints where these constraint points have a certain preset intention. For example, I want to constrain a circle to be tangent to this line. So there are 3 different ways I can do that. One would be to give the constraint when I'm constructing the geometry. For example, I can select the circle tool and create a point, and then select the tangent constraint and click on this line. So this was a manual constraint. For example, I can say that this line, I want to create a line from the end point of this line. So that was a manual. That's the step one method. That means you are using the noun and the verb and then the modifier, and then you're creating the constraint. So you're constraining it on the fly. The second way is to infer the constraint. So what I do is I select the line tool and it'll infer the points for me. So I want the first point to be at the center of this circle and the next point to be at the midpoint here. I want to create a line which starts from here and is tangent to this circle. So the constraint inference is on when it's on, the snaps occur automatically. The available constraints, this is called a free point. This is the origin or the centroid of a shape. This is the end point. This is a proportionate constraint, and we will be dealing with these in greater details, each of these constraints. The third method of constraining is what's called late constraint. So let's say you drew a line, and now you want this line to be at the midpoint of this line. So you select the percentage constraint and say 50% of this line. Or you want to constrain, you created a line and you wanted this to be now tangent to this, so you select the point here and say tangent to this. So once again, there are 3 different ways of constraining. One is to manually constrain using these constraint tools. Second is to infer constraint by snapping to constraints, and third one is late constraint. That means you have created a geometry and you want to constrain, put the constraints later. Next we will go into what we call numerical constraint. So when I'm gonna, let's say, draw 3 lines, okay, and I want the length of this line to be equal to the sum of these 2 lines. So anytime you click on a geometry, if value bar is displayed, this shows the current values which are controlling the geometry. Notice one thing though, this is different from a CAD system, that the line has a polarity here. That means it was a start point and this is the end point. If I drew the line from here to here, the polarity would be different. So the polarity of the line is from the point you start to the point you end. So let me delete this. So when I clicked on this line to open it, it tells me this is the horizontal displacement of this line, this is the vertical displacement, this is the current angle of the line. Angle is measured with respect to 0 here, and this is the current length of the line. So I want to constrain this line. If you just want to constrain a geometry, you can allocate a value to this value bar. For example, I want this angle to be 60 degrees of this line. All I have to do is to press the A key on the keyboard, corresponding key to the value bar. the value bar gets highlighted, and then I can enter 60 degrees and the line is at 60 degrees. The other way is to put this is a numerical constraint I allocated. So now this line has start point here and the angle is constant. But I can also give a this is when I allocated the numerical constraint using the value bar, but I can also say that the length of this line, this is the length constraint, we will explain it later. I could give a length here by entering the value here directly manually, let's say 40 millimeters, or I can enter a formula. In order to enter a formula, you have to click on the value that you want to allocate, and then you can enter a value here manually, an empirical value, or you can say that the length of this line is equal to length of this line plus length of this line. This formula bar operation we have explained in greater details, but for right now you can see that the numerical constraint can be given using the formula bar. So now if I change the length of this line, the other line will change. And finally, you can manipulate the view. There are a lot of ways. The mouse wheel itself can pan and zoom, or you can use this tool here is zoom out 2x, and this zoom in 2x. This is zoom to fit the paper. Zoom all, that means it will zoom the geometry till it's fit in the whole view. And this shows the zoom factor, that means it's 111% zoom. If you click on it, it brings it back to 100%. Or you can double click on it and enter any zoom factor you want. Say you want a 200x zoom factor, you say 200 here. So it'll now the geometry is zoomed to 200. There's also a pan and zoom available here. You want to zoom only a portion of the picture. So here this is a window zoom, and underneath is a pan zoom or pan tool also, so you can pan the geometry. You can also view the paper space, and paper space right now I can see it's in landscape mode, and I can change it to portrait mode here. And you can see the paper boundary by clicking on the show paper tool. It tells you where the geometry is fitting in there. So essentially these are the elements of the user interface. To summarize, these are the geometry creation tools, and these are the geometry constraining tools, and this is pan and zoom. These are view manipulation tools, and you have the calculation tools appearing here as you need them. So with some of the tutorials that we have shipped along with the software, this should give you a pretty easy idea. If you practice, play with the software for a little while, you will feel pretty comfortable because the sense of the user interface is based on existing CAD applications and existing spreadsheet applications. Thank you.